All right. It's now 5:30 according to my clock. Okay. And I've changed so that you can get some dark mode. I think for people watching, this is nicer. Personally, I don't use it because normally I don't use it because it's worse for my astigmatism. So I've written that the today is going to be a bit bug fixing. At least we start with bug fixing, and I recently got a bug report, and it's a bad one actually. It is issue. Let's just call this pointer arithmetic. So the one we're going to fix today is this one. And we can just see if we can go ahead and kind of provoke this. So this is when you have highly aligned things. So let's say I have a struct, right? Struct foo, and I have something that has a pretty large alignment. So if I get something like maybe like a double like this, it's going to have a fairly high alignment. As you can see, let me see here. I get a foo, and what's the align of for that one? It has. Okay, let's see if it's the command line properties working. Oh, let's turn off the parsing only. Okay. So what does it say? It says the alignment is as much as. Oh, sorry, folks, I forgot to import. As you know, or maybe you don't know, C3 has recursive imports. Don't do this for anything serious, but for testing it's so convenient. If I just do imports, I've imported the entire Silent library in here. Everything inside the library is available. Okay. Let's go. Oh, say it says 16. 16 is not that bad. Oh, that's probably because I'm on ARM, by the way. So 16 is actually not enough to provoke anything, any problems that you might have. What about the ints? So an int struct. Otherwise, we just have to increase the alignment. Align, and it has to be something like, let's see if I can get the alignment of 128. So and now it should have alignment, yeah. So the foo now has the alignment of 128. And now we want to allocate a huge chunk of foo. Enough of foo that we do get make the temporary allocator unhappy. So we are going to do a temp new. Alloc array of foo. And we're going to make, how much do we need to break this? Probably megabyte. Sorry, I'm getting better after very long illness, but I'm not feeling great. So now this would possibly create it. So alignment what alignment, of course, if people are unused to that. I'm not looking, by the way, I'm not looking at the chat right now. So alignment is when you allocate memory, where will you, what addresses what can you assume about the address? So is the address the actual pointer? Is it, if I do modulus 16, for example, do I get, is done as even 16, a multiple of 16? If it's that, then it's 16-bit aligned, 16-byte aligned. And normally from malloc, from libc malloc, you all get 16 byte aligned things, and that means that pretty much everything would fit into that alignment, except for some vectors. So, but in this case, it's not the vectors that are taking it, making it what's called overaligned, being more aligned than memory is usually. It is, we're just forcing it instead to be on that. Right, so let's just print that memory afterwards or something. We can just take the pointer that we got, right? Oh, I use f twice. Those favorite. Right, so, and something crashed. And it crashed in malloc. Exactly what we want to fix. Let me see what, if someone's written anything. No, it's actually using namespaced. So Toger is writing, gotta make a better C++, step 1, reinvent using namespaced. No, but it isn't the same, actually. This isn't an import. So if I want to use print, I have to write this, right? So this is, even if I am loading everything, I have to have these prefixes. So it's kind of safe to do this import, actually. It doesn't make it any worse or better compared to just maybe doing this. It doesn't change anything. So, but yeah, maybe types, but the types should be like clean, very clean too. But the problem is, if I do import std, then anyone reading this will have no idea what things I use from std. So that's basically, it's more of a communication issue. Anyway, but right now I'm not just communicating with you and myself, so it's gonna be fine. So let's find that problem. So it turns out in the temp allocator, I do a something that keeps happening. Okay. So if you look at going back down, going down, and we're going to do an acquire here. So you see it's breaking in acquire. Actually, it's not breaking in acquire. It's something that acquire calls. Possibly. Let's see here. So yeah, it's in acquire 180. Let's see if that's, because when you go to do this handle signals like this, you sometimes get to get everything but the last thing. So here's the bug that someone discovered. So you see, first of all, the alignment have to be greater than the default alignment, or this code would not happen. I mean, if you just get this and everything is fine. So what it's going to do here is going to create a temp allocator page, and then it wants to allocate memory for that. And then we're going to offset that memory backwards. This is wrong, right? So we have a page, right? It starts with a page, and then what we want is that the start of the memory is aligned. So what we're going to do, instead of doing this, I mean, this is going into unallocated memory, but there is some tricky things. So if I have some things here, like the annoying thing when you do like this is a trick. You have a header, right? You have a header, and then after that comes the memory. So here's the memory. So we have the header, and then we have the memory, right? And this is the huge memory. It's like whatever memory size of that foo times 1 megabyte of that. So in this case, you're gonna have a pointer. You're gonna relieve this pointer to the user, right? And whenever you get the memory, you can then go back, step back -1, and then kind of see where the memory is. So let me see how this works. So the alloc is the actual, right? So, and hang on. So padded header size. Right, so these work in very different ways. I think the later one is the correct one. So if I look at this one, it's going to take first it's going to say, okay, well, I don't know what the page size of the header is, but let's pad that one so it's allocated the same way or aligned the same way as the memory. So now we get the padded header size plus the size, and then we allocate for that one, and then the page is going to be the allocation plus the padded header size minus the temp allocator size off. So you you place it, if we say that the header is this big, so it's like a header. It's this big, right? And memory then followed by memory. This is like the naive thing without any padding. And now we know that we have to pad things. So what we do is we're gonna allocate this much memory instead, something like this, right? Something like this, and then we get the memory afterwards. But let's see here. So yeah, in this case we know that the memory is aligned as well. So this one is fine. So then it places the header like this towards the end, right? So it looks like this. So that way you can get this pointer, and then just go -1 and get this one. But then it also tracks with this page start where this point is. Because otherwise, if you have here, you don't know that the start is here because you don't know the alignment, so that's bad. We want to do something similar here. Again, now we're going to take all the memory, and then we're going to align it. Let's think about that. So we get the line memory, which is something like that. We have and then we have the header. So, and then we have a memory. It's like this, right? So this is what we have. This is the size. This is the total size. And then we allocate that one. All right, and now we need to first of all kind of grab where the oh wait, this is correct. So we have yeah, okay, so this is already lined, sorry. So this one is fine because it's already lined. So now the top is aligned. We just need to first take the we need to have the memory, but we then have to walk back into the plus mem aligned offset. Let's see, the memory is what? It's okay, it's a temporary allocator page, that's bad. So basically, if we take this start is mem, right? Or what was it? So okay, so void mem is something something. It's not there now. Okay, so this is the memory, and we going to store that start, and then we go forward by mem aligned offset of a temp allocator page size of, and we align that to alignment. So now we basically go from to this point. Okay, and then we from that point we align. And so from that point we can then say that the page is indeed this. So now we're fine. And now the page start is the start. And our memory is already offset correctly. Right? Maybe something like that. Let's see what you say. Oh, reinventing include bits slash C++. Okay. I'm not sure what you mean by that, but okay. So Tugger's writing reinventing include bits slash C++ dot h. My bad. Okay, that was probably a joke, but it's like swoosh or my head. Okay, let's see if this works. Without any tests, it's just going to be okay. Maybe I should remove these, my beautiful ASCII art. And that seems to okay. And that was not elegant. Printen. Okay, so now the question here is it correct now? For example, is if I'm going to do this a few times. I can do it pool. So now we're in a temp pool. Actually, this is allocating on the heap allocator because there's not enough memory in the temp pool to actually use this. But the pool will still release it. So we get the pointer. And then we can maybe we want to print what the U pointer of this pointer and see if it's, there we go, mod 128, right? So let's see what happens. Let's run that a few times. Sadly, I don't have a nice. Oh, did I turn off the tabs or something? That's weird. Okay, so, and this one is really not lined correctly. Okay, it gets a pointer, tries to look at the pointer. Okay, let's see if this. Oh, I always do this. I forget the F. Oh, not there. See. 28. This one's from here. Okay, very good. It scared me a bit. Okay, so let's verify this by saying, okay, so it's, if I change this to, maybe to 32, then suddenly I should get like off alignment or something. Yeah, so I got like 64 here. A bunch of 64s actually. Oh, I get the same address here all the time. Maybe I can just, let's have, what happens if I don't do that? Yes, I'll get new addresses at least. Just eat those megabytes. $64 all the time. And if I get like alignment 64, then I guess it's 64. And if I get alignment 128, I do get 0. Okay. Let me make that one even bigger. Right, that worked too. Alright, so it's aligned on those edges. Okay, that seems to fix the problem. So let's add that fix bug in temp allocator when temp memory is exhausted and alignment and memory is and allocation is over aligned memo. And then the name of that issue was as much as, so let's see here, it was this issue. And I'll just add that to the commit as well, but before doing that I have to run tests. So let's run tests of it. I should catch any obvious thing. That one of the things it can break is that when you play around in the memory, the temp allocator or something like that, sometimes if there are a few tests that have debug info, and debug info, if it accidentally has some line numbers in it, line numbers may change when changing the state statically. When you change the Enum library. Okay. Any questions so far? Everyone is silent on the chat. Okay, I don't think we actually need to look at all the tests. They're like they are a little slow. These are starting up the compiler, running the compiler, and then turning off the compiler. So it's could be faster, could be slower. Okay, I'm doing a little comparisons and stuff like that. So let's assume that this works. Otherwise, I guess I'll have to fix that. But it seems reasonable that this was enough to fix the problem. So that is that bug fix, and so we're done with that. So what can we do next? So the other thing that I was looking at recently was the question whether we should add this. So typically I have a const. I might make it distinct. Sorry my usage of foo and so on, but I just don't have any. My imagination is running low. So I can have something like that, and it's called bar, and it's 12, right? And then we can have another one, and it's 13. So this is the recommended way of taking an enum. Like, let's say you have an enum in C that looks like this, and it's just basically bar. So something like that. If you have this in C, then you can turn it into this thing, distinct, because then you can have something like fn void, let's see, and it takes a foo, and now you have to do like this works. So test bar works, but if I try to do like 3, okay, so if I run this, if you see the stuff like passing by. Oh wait. Oh, it's a number. Sorry, this is special. Well, let's have a. The thing is that if you have a distinct numeric type, a literal, then any literal will implicitly convert to a distinct type, and that's to make it easy to do something like IDs and stuff like that. But if I have a variable which has a type in there, if I do this, now it's going to be unhappy. Like implicitly casting into foo is not permitted, but you may do an explicit cast by placing foo before the expression. Okay, so I can cast it, right? So I can do a foo like that, and now this works, right? Even though it's not one of those constants. So it's kind of like, actually the behavior is like C, right? Right? Even though I think would most of the things today, most of the compilers today would kind of warn if you try to just pass I here. But you might not be happy with this. So what you can do is you can create a separate module. I'm going to put it elsewhere, so I'm going to put it like explain why later. So it's a test foo, maybe like that, right? And so now, rather than doing bar, this will not work. So globals from other modules must be prefixed with the module name. So you have to do it like this, right? Now that works. This works because test will implicitly import its submodules. And this is the reason why it will import its submodules exactly to allow this. So okay, now we have like the foo here, right? Nice. And that looks very much like, if you don't change this, it looks like an enum. So it's kind of like enum-like. The problem is this, right? You might want to, you're declaring stuff and you might want to have it in here, but then you would have to start the module test again and import it again here, which is not so nice. So one way of doing this would, of course, be like this, right? What about this? Right, that could work. Now we import the module and then we do this and then we go back. We could imagine it works like that. It doesn't work like that, but that's a possibility. Right. But there was another idea. So the idea was that it should look like this. So let me just comment on this. I love this about the comments, that you can just start it and then you don't need to end it. And it's recursive, so I have a bunch of junk down there. Maybe we can look at that later. So okay, so instead of doing that, I could just do foo. Like, oh sorry, not there. I would just change that. It would put it here. Right, okay, it doesn't work now. IntelliJ is in syntax highlighter. Oh, sorry, I have to. Still a bit sleepy. Okay, so that this would actually be the same as creating a sub module to test called foo, and then place the const in there. So this was something you could then think about as an alternative to having C enums, right? So I was actually testing this out. The problem is, I don't know if people spot the problem, but actually there is one more feature for that. So you can also, make let's make a new foo, and this returns, one or something. Okay. This way, you kind of create a constructor using this syntax and it's placed in that submodule. Okay, it's not a big thing. If you want to read more about this, let's see if it's an issue. Look at that. It's actually a proposal from me, so this is why, like, it doesn't matter who's making it. You still have to think about, just because I had an idea doesn't mean it should go into the language. Most of the things should not go into the language. So this was it. So in someone it's like 1513. It says support ad hoc function and type submodule declarations. Like this. Anyway, okay, so the problem here is, if you start, there are two forms of const. So you can do const abc equals 1. And this const is special in that it will not have memory location. unless you actually take the address of it, but usually it will just be copied. So if you want something that where you want to be sure that it's just handled as a by copy, then you can do like this. If you type it, then it will be placed in memory. So there's this way of doing the making sure that's in memory. Memory mean compiled into the binary, and this will be just copied around. So which can be expensive or cheap, depending on what the constant here is. I mean, this could be a large struct too. Okay, so what's the problem? Well, when the compiler goes through const and comes to the next thing here, it doesn't know if this is going to be a constant or a type. So it looks at whether it is a constant token identifier. So if it is like ABC, yeah, then like, okay, there's going to be this kind of form. If it's anything else, then it's going to parse the first part as a type, and then followed by the name. Right. So, but in this case, what happens if we have something like foo bar equals 12? Well, it's going to go here, and so like looking at this first token, it's, oh, that's an identifier. So maybe that's going to be like a type or something. So it just goes ahead and tries to parse this as a type. And that's not right. And there are ways around this. So the way around it that I use is that would be like, instead of doing the like look at what it is, it's like then I just assume that this is an expression. And I can use that because this is an expression, and actually this is an expression too. You can have a type expression. It's just going to be special in how you use it. So you can look at that. If it is a type, then you assume that there should be a type. If it's a constant, a single identifier that is a constant, then you assume that you wanted the other variant. And this kind of thing will be somewhat handled somewhat differently. But it's also, I mean, whenever you have something where you notice that where the grammar will become a bit more complicated, that's when you should worry, because this also means that when you complicate the grammar, then you also complicate readability. So even if you thought this was super clever and nice, you have to then sit down and kind of look at what you have. And what you have is this. And to be fair, this is not a perfect way of writing something like Enum. Right? This is not clarity. So adding that feature just to fix these issues, that's not great. Then there are issues in the handling, which is more. There are other issues too, because once you throw this creation of a module in here, but that module is never defined anywhere, you get a bunch of special cases. So, for example, if this is a generic module, then the meaning of creating a submodule is a bit unclear. Is that like a generic submodule, or is the normal? And if the generic one or normal, does that match the definition of when that submodule actually maybe might be used or written explicitly. So yeah, this is probably not going to be going well if I pursue this. It was an interesting idea, but it's not going to, it doesn't feel good. It doesn't feel good after giving it a spin. And so we're again back to square one when it comes to having something like the enums. I mean, we still have that const, so the const foo bar and const foo baz. This is still working, right? You would want something like something with this semantics, but it's like enum const foo, and then you have bar equals 12, baz equals 13. But then you still want the feature of having like ABC 45 to kind of be useful. But now it's outside the const definition. So I don't know. Would it be like even const foo could be extended in a way like this? Then maybe it's a bit more palatable. With something like, okay, let's append to that. But this is like a huge amount of syntax. This is this is in itself just as much syntax as you add for enums, or more than you add for false. So it better be used a lot, but the problem is that it won't be. It's not that much. It doesn't have that huge amount of usage. I mean, enums are so comparatively unimportant that Go didn't include them, and PHP doesn't have them. I mean, PHP doesn't have them. They just run with the constants. So I don't know. It's natural coming from C that you really want it. It's just hard to make it a sufficiently small but sufficiently big feature that it matches expectations. Let me look if someone wrote anything. Is there a way? Slow looks here. Okay. Toger says, well done, fix my code next. Okay, paralyze the tests. Yes, I could paralyze the tests. It's just that they are not that. Well, actually, they are very slow if you run it on with LLVM on with the full debug. Then it's excruciatingly slow. But yeah, I could do that. It's just actually still a Python thing, which is really ugly. I mean, I can't read that code. That's probably the worst code I've ever written. But I was going to go for a see-through version. I can thread it then. Put my ideas into the language instead. All my ideas are great. Sure it is. Sure they are. All the language ideas are great until they actually have to implement them. I had a lot of ideas for C2 back in the days. They all sucked. Except maybe for adding defer. So, okay. Anyway. Is lowercase foo dot colon a namespace here? Yes, foo is the namespace. Actually, foo is giving you a sub module. Is there a way to express the underlying type and the const values of enums? Right, yeah. Enums. Normal enums that do have the type. Similar to enum class. Expressing them nicely is a problem. Yeah, expressing them nicely is a problem, and it's just it's kind of icky. So enum is essentially a set. Yes. C enums are a set, but if you look, let me show you some examples where it isn't. So I have to go to, let's see if I can jump to that. If we go into, maybe I should just some Apple code. So what happens when you want to evolve an API is that you might have like the API version, like the API that you have is 1.0, right? So 1, and it has let's remove this as well. So this is how it looks like, right? To begin with, and I mean you could have locked the. I mean in C you would have locked values like that. And then you discuss, you want to have like the API 2, and then you add another, right? So, wait. Okay, so you get like bar, and you have Baz, and you have ABC, and it's 13 or something. So, if you are compiling with this header, everything is fine. If you're compiling with this header, then you will sometimes get enum values that don't make sense, right? And this is fine, right? And then we get another version of the API. But then they decide that they want to deprecate, they want to deprecate the bar. Or hang on, we're just going to do the simple example. So let's say I know that later on there will be API 2, but I'm this one. So my code looks like this. It does switch X and some, right, and it has cases bar, and do something, cases Baz, do something, and now I can actually do like this. I can define, because I know that will be an ABC. So it lets me define the ABC to be 13, and now I can just in here do like that, right? I can mix them because they're just just plain constants. So this part here, this is like OS header, and this is my code. So now I can support this even though I don't link with that, I don't use that header, because I know that this will happen. You can't do that with enum class in C++, but you can do that with C. And you can also do some renaming. You can do stuff like, let's say, right, this was the first version. and this was the second, and then we wanted to have like the new one. They wanted to change this to, they want to change it like this, right? Next API, but they don't want to, this will break everything. So they can do like this. So a const, right, or define bar as this, right? And now you can use the new, it can still compile, and then you say that this is deprecated. You can have a const, right? Const API 3 bar equals, this, something like that, I guess. In C, you would have to do the define root, right? But the point is that this gives you a nice, it can you can make this nice way of upgrading. You can make bar masquerade as part of the enum, even though it isn't, even though it's deprecated or something. So these are tricks, but once you go out and have like an enum, a proper enum, then these two, there's such a huge difference between something like this and something like this. So for example, in C3, if you have something like, a const is, so a const bar, let's say I do this, right? So let's say we really have this, right? Then still they would be used differently. So if I would do a switch over this API 3, then actually this might work, but you can't, they are not the same. You can't do like API 3 bar, right? This is not okay. You have like this works. This is okay. This is error, because bar is not part of this body. You can still do this. This is fine. And actually you can do this. But some of them will always give like this. Okay, it's a little bit different. And things become actually, this is because of that. If you have some other way of doing it, it could be worse. I don't know if that answered the question. Do you want to lean towards the C way of enums? No, not for enums. I think that there is such a huge value to having enums the way they are. So let me see if I can show some enum examples. Maybe in the resources, in the examples. Let's see if something. Enum. Right, so, that happens to be actually a conversion of something else. So let's take the snake one, right? The relive snake. So here, let's see if I have that. Is that the right one? So that's the snake direction. That's the grid snare square. These are actually, well, okay, let's look at the snake direction. So here we just have an enum, And I think we'll clean this one up. So here you get like the from ordinal kind of thing and the ordinal. So let's look at what that would look in a more C-like way. So you would not have from ordinal, right? You would have just a cost. And rather than getting the ordinal, you would have a cost. So you would have these costs where you take the snake direction, your cost to just turn int and handle it, and then mod, and then you get a snake direction. And I think this is actually worse than having it like this, because here it's very clear that you're doing this transformation on the ordinal and getting it back and forth, whereas here it's just some number. You don't know why it works. So I think this is kind of more integrated where we have an enum and it has an ordinal and then might have associated values. It's nicer to reason about, really. But that said, it's not the convenience and quick hack of having C enums. But I think the thing I dislike the most about C enums is that you can't dump them. You can't get name of an enum in a simple and straightforward way, because they might be duplicated and so on, and you have to have like you do a map or like a manual mapping, or you have a switch statement or something, and that takes a lot of time to maintain. And X macros, they compile, or actually they compile fine, but something like CLI, which I'm using here, it really can't keep up. It really can't keep up. It's like the worst thing when you refactor them and you're kind of in the middle of refactoring an X macro, and it's just it just locks down the entire environment. So that's bad. So sorry. Sounds the C plus, yeah. All right, yeah. So no operating overlay to make snake direction plus plus work. Snake direction plus plus should always work. I think plus plus is a normal thing to happen if you have an ordinals. If the backing thing of some enum is no, I mean plus plus is not. I would just assume that you get the next ordinal. The only question is like when you do a plus plus at the end, what do you get? But I think that, I mean, if let's write an ordinal. You have an ordinal, so it's called foo again. Sorry about that, and it's called, maybe today is like something okay. So Merry Christmas, Santa Claus, Elf, 12. Okay. Okay, so if I have something like this, and I start with foo, F is Merry, and this uses the type inference. So actually the full name is foo Merry, but you can do type inference. So that's how it works it's like the class enums, but you can infer a lot in C3. Most languages would have you do like this, but it's the same. So okay, so then we're going to go for how many times do I have to do this to see what the behavior is. But then I just go, this will crash, by the way. So I could just do F++, right? So now it will print it and then get the next one. I think this should work. Because this is not completely fixed. Yes. So you get 12 and then it crashes, right? Illegal Enum value found. So you can overrun it. The question is, something I was thinking about, like, was actually basically make it start from the beginning if you can reach the end. So yeah, this should always work. I think this is like a super important thing. The override you always add to enum classes in C++. It's so insane that it doesn't exist by default. But okay, I think it's natural to have this. Go to the next enum, go to the previous enum. Like, why? Seriously, why not? Okay. Any other questions here? So, for direction, you wanted to loop around, right? Yes. But it's not clear that you always wanted to loop around. I mean, it makes sense to actually loop around, but it would be an extra instruction. There would be this extra comparison if it's so and so much. You don't want to have mod, you would have to, maybe you can have like a C select, right? You have is the number is something, is the number the last number? If so, then you get the 0, and otherwise you get the other. So yeah, you could probably do it pretty efficient, although not as efficient as not having it. So there's some semantics to work out. And right now this only works because the conversion, you can have an implicit conversion from int to enum. Oh, by the way, so an int, when I say an int, it could be an int or it could be like a long or something. You can store whatever you want. This would be fine. So that would be the inner type of it. But this is just basically the storage type, right? Yeah, I think that's pretty much it. So sitting here for an hour now, right? Any other questions? Let's see if so there is. So interestingly, this works. I mean, I remember I did this change. So if I have something like this, I can do this from before, right? So you can do it like this, and you can go. So I can get something. Better have it as a number separately. So I can do like this, or I can do the other way around. I can then get that one and get. So this still exists, and this is what we want to remove to make it more clear that enums are not C enums. And if I run this, you might see here at the bottom. So using cost to convert into integers to enums is deprecating if we're using my enum from ordinal. But this one doesn't get. So if we remove this one, so if we do this from ordinal, so now it's happy, but it doesn't complain about this part, and should complain. But the problem is, it's a big problem. So if I go to that particular piece of code, it's a cost. So cost from enum to various. Okay, that was not in the symbol. So cost, and we want to go from int to enum, right? No, enum to int. This is our deprecated code. This is how it shows up. Int to enum. Wait. Enum to int. To int, please, right here. So let's say we do something similar to this one. Actually, that just happened. So if I using cost to convert enums to integers, deprecating in favor using the enum ordinal. Right. Okay, so let's say that's what we want. And yeah, so you think like, okay, I get that error, but you get a lot of them. Because the entire send library is using it. Okay, so what actually happens, right? So even though we're here, like why using const to convert enums? So let's just go past this because this one is going to give us. So, oh, right. So this is weird because we did use the ordinal because the ordinal itself. Let's go to that usage. So here we want to convert an enum to an int. Oh, I seem to be running out of battery power. So, okay, then we looked at, okay, so I convert enum to int, maybe it shouldn't be there, right? So instead, we wanted to put it just on the cost. Okay, now it should be fine, right? Everything should be just perfect. But I'll just get that one. Okay. And that should be fixable, right? So I just, okay, let's do this. Okay, everything is fine, right? Now it compiles and the library doesn't seem to protest, except if we run our tests now, I'm gonna find a few cases where this happens anyway. Meanwhile, well, have a look at this chat. So let's see. Okay, Ajik is quite high up on the latitude. You must have snow. No snow now. It's like extremely pretty warm now. It's plus 6 degrees Celsius. But yesterday had nice snow actually for Christmas Eve. Okay, I can do enum foo a equals 2, b equals 0, 0, and then a plus plus becomes b, right? Yeah. So actually, it will just walk through the ordinals. So it doesn't matter what to assign these actually extra values to. Okay, so now we already have one error here. That's strange. So let's see what that was about. So enum costs, right? Okay, that one's going to have a bad experience because it just do these costs that are forbidden now. But we're going to have something else. We just have to wait for it, and yes, having it work in parallel would be nice. Although it would be a bit hard to read. Okay, so here we go. Let's see if this one is so array indexing. Okay, so we might want to do this, right? So you might want to have the enum work as an index, right? Not use the ordinal, but have like this. This is not a great example. But let me paste it here. So something like, okay, so let's say like elf, right? This might not be a great example here, but you could easily imagine that you wanted something like foo, right? Give me an array that has as many elements as foo has, and now let me index it using foo equals minus 1 to 3, right? Wouldn't that be neat? I think that would be neat. And there is already something called an enum set. So we have the enum map and enum set. And they are essentially this, right? You can also print them nicely. But so the question is, what do we do? Do we introduce this or not as a syntax? Is this good? Is this important? Important enough that you have it built into the syntax of the language? I mean, you can always do, foo, elf, ordinal. That's not a problem. But doing this, this especially, is more clever code. So maybe. But if you have it, I don't know. If it's static, then you can assign it to this, right? So if you just want to have some extra, then you can have something like this. And you have your mapping. If the idea was to map something to a that's static to a foo, right? You can now do it like this. If and you can always do the ordinals, and you can have the enum set if that's a problem. So maybe this shouldn't be in. If so, then we can just ignore these kind of situations. We have the enum ct sub. So here's another one, another kind of thing you have to handle. So here, what's the difference between two enums, right? What's the addition of two enums? I think it makes sense to maybe support this. Not this. I don't care about adding enums together, the ordinals, without grabbing the ordinals explicitly. But maybe this matters. Maybe it doesn't. So and getting the next, if you have an ordinal, this, get the next one. Otherwise, if you support this, if you support plus plus, then it makes sense that you have like f. If you support plus plus, then it makes sense that you support plus one. And if you support plus one, it makes sense that you support f plus one. Or f equals f plus 2 or something. And if you have this, then you have to think really hard about how do you do the costs. Because you don't want to do the cost okay, it's actually an int plus an int, right? But do you think of that as, okay, let's cast this into a foo, and then two foos can be added together to produce another foo? Or is it like a pointer? So you can't add two pointers, but you can add a pointer and the offset to pointer. So you can have let's say we have a pointer to foo, right? Right. So you can do f plus 1, right, and get the next foo if there are multiples. And you can do take two pointers. Oh, sorry. So you have a pointer. You can do plus 1, right? And you do that internally, not by casting this 1 here to a pointer. So you add two pointers. No, you just keep this as an integer, as an offset, pointer offset, and then you add that to a pointer. So pointer an offset can be added to a pointer, or an off, so it could be the other way around too, but you can't do a pointer to pointer. This would be error. So this is bad error, right? So then thinking about enums, so maybe you can't add enums, but you can certainly take the difference between the two enums, and you can certainly take the addition of one enum to another. So the question is just, okay, so you add two enums, does that addition bring you past the end? And is that an error? So if I do, we have already, let's say f is 12. When is like adding, is this an error? Panicked even. Or what about like f plus 4? No, do we have an error? I think it would be easier if it wasn't an error, actually. But obviously then trying to access it, or like it's an invalid thing anyway, so trying to access, for example, its extra value or something would be broken. But the alternative would be like this one returns, becomes the Mary, right? And if you have something like this, then you basically go 4 steps. So 1, 2, 3, 4, and you add out with clause. So that's the question then, how that should, wrapping around, if that should actually happen or not. Because it's a C-like, I tend to think that any of these kind of checks should be, maybe this should, have a check here, but it's not. It's going to check only in safe mode. So you can't go past it. There's a one problem with not being able to go past it. So I'll show that. So if you have something like this, right? If you have an error on wrapping, then this will give you an error, even though the result value is going to be fine. So one way to do that then is to have just make sure that the end of some assignment, when you assign something, at the end here it has to be the right value. And that's kind of a probably better idea. Okay. Let's see what people are saying. Okay. So I think it's like it, and I feel like isn't extensible enough. I want foo plus 3 and foo plus bar. Of course, holes in the enum spring and everything. Yeah. So maybe enums should be directly indexable. Yeah, what I have to do is kind of like always. You can't really make. You can do some exploratory coding, so you can make some changes, see where it takes you. Like start implementing parts of this, and then if you're not happy with the feeling, you can stop. Go back, try to fix it. To do this, there's a need to add another thing in add and subtract. So when you have something binary add, Let's jump. So here we go. Schema analysis. Okay, so it's kind of a. Actually, this is one of the more complicated things in like the add. So because you have to think like if the right thing is a pointer on the left is not a pointer, then here we reorder it, right? So now the left is always be a pointer, and then we see like is it possible to do the offset thing. In add you can also always reorder them. And what we'd have to do is to add something as big as this, but for the enums. Oh, here we have, we actually analyze enum add sub. I do it differently. So enum minus enum, enum plus enum, right? So if the right time is enum, and then we do the costs. Well, maybe I can do it something in a clever way here. Oh, this is interesting. So if you do like this, I do like so foo elf plus foo elf. This will actually give me an error. At compile time. Or should. Yeah. Okay. Maybe the shrines. Do an int. Implicitly casting in something. Using cost to convert enums to integers deprecated. No, I was casting int to foo is not. Okay, we can do it like this. Oh, that worked. I have no idea. It should seem like it shouldn't, because you did have go into this, right? Both were const. Oh wait, it's not even hitting this code. That's strange. So it goes in here. The right type is an enum. They're the same, cost explicit, both are const. Okay, we'll add both and then we're done. And so this piece of both are const, it's never called. Yeah, great code. If true, lets me just assert false here, and I'm going to run this code. So the clever kind of let's catch the error, that was gone. It's like twice as long. That was, yeah. I I don't think you ever hit this part of the code. No, it doesn't look like it. So that's funny. So wait, maybe it's okay. So wait. This is like the enum plus value. So if you have an enum plus enum, it's like always fine. But if you have enum plus something, then you can go into this piece of code. So if you have something like, it's going to protest if you do this, right? So if I have something like this, let's see, right? And now it's going to protest. Because now on the right side, there is no Enum. Okay, come on. Okay, something happened because now my computer went super slow. Oh, this happened before too. So let's see. Yes. Now we're in there. We hit that one, right? Yeah, we hit insert. Okay, then we can move this to insert. And then maybe, yes, maybe, because my computer went super slow, something is eating my CPU. And it's, yeah, part of it is C-line. Yeah, C-line is going bananas right now, I think. Maybe I have to, so, but just let's just run it one more time. I think I'll wrap it up for today. It's been 1 hour and a half. And thank you, by the way, for watching. So I do this exploratory coding too, except when I end up in a dead end, I dig deeper. No, don't do that. Always like when it gets hard, just you can put it in. I mean, if you don't want to abandon it, just put it in Git on some branch or something, but don't keep it. Just the one. It's really nice because code is always giving you kind of feedback. So when you get like complexity, you can see like it is. Sometimes you have to have complexity, right? But you have to make sure that the complexity that you do have is the necessary complexity, the one that you get from having a problem that is complex, and you solve it in a in a reasonable, pragmatic way. It is not nothing else. So okay, so we got that. This does not result in a valid enum. If you want to do the addition cost into an integer, right? Okay, that makes sense. It's a little like, by the way, it's like I think like I don't know code, right? So if you are, oh, I thought my computer was loading, but the battery wasn't in. So okay, now my computer might get a bit more happy. Probably was preparing to shut down everything. Okay, so if you do add into code, you're gonna run into places where the naive solution will take until the end of the universe, or at least it will take years to complete. Right, the brute force one, and that's when you have to think like, okay, the solution, I like the solution, but it's not good, right? And then you have to figure out which solution kind of gives you um, the enough the enough what how should I put this, right? It should be for the effort you put in. It should get you good enough results. So and sometimes you have to shop around a lot to kind of try different things until you find the solution that you can actually that is actually workable, that gives you a decently fast solution, right? In Advent code and such competitions, right? You don't need to do the perfect, but you should absolutely not try to brute force it. And so you will get the feedback. Well, if you try to brute force something and you notice, okay, it's like I've given it a minute, how far has it gotten? You know, if it's gotten halfway, that's fine. If it's gotten, you know, it's going to have like 1 billion, 1 trillion times longer, then that feedback is that you should now already quit it. It's not going to help you. No, nothing will ever help you if you use this algorithm. And in the same way, this kind of resistance that your code has towards change, it is giving you that kind of feedback. So if you notice that, okay, the grammar is going to be like, I have to fix this and this and that, and then you look at the code, like the value of what you're actually getting. Like in the case of, what we talked about in the beginning, the this kind of const foo ABC solution. Like, what do I get? This isn't exactly nice, super nice thing. You say, yeah, maybe, kind of maybe thing. If this was giving me something really nice, then the cost of doing it would be worth it. But I know that the cost of this is going to be much higher than the value of it as a feature, and so you have to kind of consider. I mean, okay, back up one step. So the cost of a feature could be extremely inexpensive or extremely expensive. So depending on the rest of the features, something can be easy or hard to add. And so when an addition comes in, you kind of know, okay, this, what will I need to change to accommodate this? How many other functions or similar will be affected by this? And that's the cheap, or not cheap, like the cheapest features are like, oh, okay, I just add an attribute to this and it just works. Or yeah, I can just allow it to take this extra argument and then it works. That's the super cheap things. And if that was the way to solve this, then it would be totally worth it, right? You could add this and it would be worth it because it would be a small thing. But now it isn't. It's not a small thing. So the cost is higher. That means that the value of the feature and the look of it has to be much much more valuable, much more good looking. That's my advice anyway. So it's kind of giving you the feedback. I had to figure out to use C groups because client give you all my RAM. Yeah, I always use a lot of. I always have a lot of RAM on my computers. So this one has. Well, I think maxed out on this MacBook Air, so it has 24 gigabytes. Anything small is kind of just get enough RAM if you can. That's Anything else, like I don't care, is particularly about the CPU, how fast that one is. But the RAM is just get enough, get as much as you can. Okay, I think I'm like going to wrap this up here. So I promised I would just look at what was down here. Just keep testing things. I think this was someone had a problems with Raylib. So let's see if this compiles. No, the Raylib thing isn't there. Then let's remove that one. Let's see if there's something more fun. Effort result. Oh, this looks like a test of some sort. Oh, okay, I remember this one. This is for returning values. Okay, okay, this is nothing interesting. I probably got this from the final version. So, oh, I'm getting this. It's been called, this file has been called debug stuff from the beginning. It's just, okay, I just had something and just did some debug, and now it's like that. Okay, thank you for watching, everyone. I hope everyone has a great continue Christmas day and Christmas holidays, and yeah, I'll try to keep up and do streams now and then. It's right now it's mostly because I have been sick, so I have not been able to work, and it's been the holidays. So unfortunately, I probably have. I can't promise I'll do streams later, but it's been fun. So have a great day, everyone. So goodbye.